Today I'm doing a two-parter on curriculum learning. This time we're going into the ins and outs of curriculum learning and understanding the charts that come out of TensorBoard so that you have a better understanding of how your curriculum is working for you. Just wanted to take a second to thank all my Patreon subscribers who are helping me with the production of the show. And if you find the show useful, you can check out our Patreon down below. If you're not able to participate with the Patreon, it's totally okay. A like, a share, or a subscription is a great way to help make sure that this series keeps growing. Hey everyone. All right. So there's going to be two videos on curriculum learning. The first one that you're watching is going to be understanding curriculum learning, and then also understanding how to interpret the graphs that TensorBoard is giving you so that you can kind of understand what's going on under the hood, have some things that you might want to be looking out for. And then the other video is going to be the actual implementation. So if there is something that you see and you're like, all right, I really want to give curriculum learning a shot, the other video is going to go into how to actually implement that in Unity. I will say that other video, more than some of the other implementation videos, I think is useful because I found the documentation a little vague and lacking in a couple of areas. So I do want to mention that you might want to check that video out before you just go diving in and then you're looking at the documentation and it's like, what is a reset variable and where do I find those? All right, so as our baseline, right, doing good science, or at least good-ish science-y things. Here is our PPO, and this is our most successful PPO. That's because we ran it over 10 million iterations. So we had a very, very long run. This was one of those runs that took me overnight and while it was at work. And then here it shows the episode length. And you'll also notice this info lesson is flat. That's because for PPO, there's only one lesson, right? You give it a problem, and it takes that problem, and it tries to solve that problem. With a curriculum, what you try to do is you set up various lessons. And so you basically have a couple parameters. One is your starting parameters, right? What does the problem look like in the start? And then your following parameters say, how good do I have to get at the current problem to move on to the next problem? And when I move on to the next problem, what are the parameters that define what that next problem is? All of that goes into a JSON file that's fairly straightforward, and I'll show you that in a second and then go in more detail on the implementation video. So as you see, we have our PPO, and we start at 0, and then we end at 14-ish after 10 million iterations, and it had been running, it says 1 day, 8 hours. I don't really feel like it took that long, but maybe it did. So this was a very long running execution. And so one of the benefits of curriculum learning is that you can get the system very good very quickly on a simple problem, and then you give it a harder problem, and some of that knowledge should carry over from one to the next. And so you're kind of preloading parameters, right? They're preloading weights on the neural net with an easy problem so that when you get to the harder problem, it doesn't have to explore quite so much. So going down to our curriculum charts. So I'll just start with curriculum 1, and I set these at 2 million iterations because I wanted these to execute more quickly so that I could do a whole bunch of runs. So this first graph says, of the lessons that you have defined, how many have I completed, right? So for PPO, it's 0 because you haven't really defined any lessons. It's just the initial starting condition. This is our first attempt at curriculum learning, where I had my thresholds for success way too low because I used the default values. So there's two ways you can do threshold for success. It's by the amount of time that your episode is, right? So if you're episode length based problem, you can just use that, or your value. And so I've been using value because we've used that. Now, keep in mind the value scores for a successful game. We've been considering, there is a theoretical maximum of 50 points. we know that our programs aren't going to be getting anywhere near that. And so what happens is you end up with, much lower scores, and 20 is absolutely a superhuman score for this kind of thing. If you're averaging 20 points, that's really, really good. And so I will consider that a threshold for being superhuman. Now, in this case, I used the default thresholds, which were like 2 or 3 or something. I didn't really understand what was going on in the config file, and so it just burned through all of the lessons nearly immediately, and then did PPO from there on out, right? So the last lesson will just keep going, and then it's PPO. And so you'll see in this area, the result is that we got very PPO-like behavior because, we ended up in a similar state doing a similar kind of problem. And so, we got same kind of results. And if we had let that run for 10 million iterations, we would have probably gotten a similar curve. So that was the first shot. But that's something to look for. So if your lesson just shoots up, right, and especially if it skips a whole bunch, that means that you have some lessons in there that aren't really doing anything. You should probably think about either making it harder or removing some lessons. Maybe you don't need that many lessons. All right, second try at the curriculum, similar thing, right? Just shoot straight up and then flat lines at 10. And so we get, again, very similar PPO type curves. And I was doing this for a while until I was really figuring out what was going on. So this one, I made it much harder. And what happened was it learned in the very beginning how not to die, right? And so it learned very, very well how not to die in the very first lesson. And then that's the knowledge that it carried on to those additional lessons. So you need to think about what are we really teaching it in that first lesson and how do we carry that information on. So it learned completely how not to die. That's the information that it carried on so that in those later lessons, it still knew how not to die, but it never really got to the point where it was improving its score. So that's something else that you want to be on the lookout for. And I canceled that one early. You can see that I just killed it at 1 million iterations because it wasn't getting anywhere. Let's see here. 5. Now this one you'll see that these steps are a little more spread out, right? It had to work a bit more on each lesson before it moves on to the next lesson. And that's what I think we're really looking for. Unfortunately, I'm not sure what the heck it learned because as soon as it got to those later lessons, it just tanked. So I canceled that one early. And there's a couple of these where, again, I said, oh, well, they went through those lessons too quick, and then I just canceled it. And so finally, I got to the point where I'm getting a little better at this. And so now these lessons are much more spread out. It has to work a bit for each lesson. Now, in the earlier parts of the games here, you will see that it does quite well. Now, it's easy to do quite well in some of the early games, although you'll also notice here later on it does fairly well in some of the moderately easy games, not super easy. And then again, we peak over here, and then once we get to the really challenging games, it starts to tank and is actually performing worse than the PPO did. That said, I will say for, I think it's 8, 9, and 10, this hardest lesson, right, or these harder lessons were actually more demanding than our baseline game. So remember, I have that scale, that score scale. The further out you are with a low scale, the further out you are, you'll still receive points. And then if I scale it up, basically that makes the bubble in which you actually earn points much smaller. And so what I was able to do in some of these curriculums, I was able to get our lander to actually inconsistently but successfully attempt to land near a very, very close proximity to the target. Much closer than I was able to do with PPO. Because with PPO, if I had a very small, very accurate target, it never found it enough for a statistically significant amount of time for the algorithm to pick up that that's where it should go, right? So in this case, I was able to start with a very broad goal, and then I was able to bring it in and narrow it in and focus it more on a smaller target. However, because it was so focused on the smaller target, it still crashed a lot. So what we're finding here is that there's no free lunch, right? We can get really good really quickly at an easy game, and we can target things more, but haven't found one yet that's really getting it to the point where it's really kind of a super player at this game. So again, we ended, let's see here. We ended at lesson 7, which was very aggressive. It had a low cumulative reward by the time we were done, but it also had a long episode length. So again, this is one where it has learned not to crash, but it hadn't really found the target reliably enough. The other thing that I will say, though, is you should be able to continue something that you've trained in a curriculum. You can go into your brain config and the parameters for the learn.py and move it from a curriculum to a standard PPO, because it uses all of those placeholder variables that a standard PPO will. You should be able to actually just pick up where you left off if you say, all right, I've gotten really close with my 2 million, and now I want to run it overnight for another 8 million or whatever it is and improve upon it. So there is a lot of potential value and use for it in that case. And again, so here we got a long episode length. It just wasn't, the episode length wasn't close enough to the target. So this would have been a really good one if we wanted to just kind of keep continuing that out and see where it got, because there's a very good chance that if it had learned not to crash and kept on going that way, that it might have actually gotten better than our big long 10 million. Curriculum 9, similar thing, right? Long episode length, lower score. So it's living longer, it's in the wrong place. Curriculum 10, so again, I'm refining and improving my lessons. In this case, I've actually started packing fewer lessons into a session. And so you'll see it learns really good at the beginning. And this is very much a, here, why don't I just show this one alone? This is very much what you'd expect to see out of a reward graph with curriculum training. As you start and you get better, just like your PPO, and then you learn something and you get really good, and then you go on to the next lesson, and so all of a sudden you're really bad, right? And then, but there's a quick recovery, and then you get better, and then you get bad again, right? And so that is an absolute telltale sign. You see these lesson changes line up with spikes and dips. And it looks even more dramatic because you go from your best because you've gotten really good at something all of a sudden to your worst because now you're on a new problem and everything that you previously learned no longer applies. Continue. In this case, for the 11th run, I had made the problem the initial conditions for moving on to the next lesson too hard, and so what we end up with is just PPO, right? So that's kind of a worst case scenario, is your lessons aren't great and you end up with PPO. And then curriculum 12 I'm currently running, so let's see how that's going. Oh, we have moved on to our second lesson. So again, things got better and they're doing pretty good. And then there's a dip right as we move on to our next lesson. But the good news is we have moved on to the next lesson. So this is encouraging, and we shall see how this goes. So those are the graphs. Those are things to look out for, right? Be on the lookout for, lessons that are effectively skipped. Be on the lookout for lessons that don't progress. So what goes into a lesson? Here you go. So the measure, this is telling the system whether or not it should be looking at reward or episode length. And this part is reasonably well documented. The min lesson length, so this is how many times it has to achieve that score. In the documentation, they have that at like 2 or 3. And for a problem that has a fair amount of randomness, that's not nearly good enough because you could just luck out and get it a couple of times in a row. So I have this cranked up to 15. So I want to be able to show that I'm consistently able to solve the problem at a fairly high score, and so that we're able to move on. Signal smoothing is true. I haven't gone into all the details of what signal smoothing is actually for. Thresholds. So this is how good do you have to be to move on to the next lesson, right? And so we said 20 is like superhuman. And so I want the computer to get really good at a problem, and then I'll give it the next problem, and it's going to take that dip. But I want it to get really good. So here we are. So our threshold is 20. So in this case, I have 4 lessons. The initial condition, and then, so that's kind of lesson 0, and then the threshold for lesson 1, 2, and 3. Now, your values here are going to vary greatly depending on, what a high score is for your game. So here is probably one of the most interesting things, I think, for the curriculum learning, because it really allows you to pass in parameters to your program. And one of the nice things about this is even if you only have one lesson and you're just basically running it as PPO, this is just a convenient way that you can parameterize some stuff so that if you're playing around with values and you say, hey, wow, I really want to try, a high reward for this or a low reward for that, you can just have it in this JSON file. And the Unity machine learning stuff already is interpreting this and putting it in. And so it uses that automatically. And so it's really just a nice way to have a runtime configurable, penalty or reward or environment change or something like that. So even if you're not using the lessons, there's still actually some things in here that are kind of handy. So the distance scale, so that's what we talked about before, where the higher the number is, the harder the problem is. So in this case, I have 4 lessons. Initial condition, 0.1, very easy, huge field. You can get points just about anywhere. And then 0.2, 0.3, and 0.4. And then on collision points, this is my crash penalty. Right now, I feel like I am crashing way too much. I really want to penalize the computer for crashing. And so I'm being very demanding and said there's a high penalty for crashing, and I want a high threshold to move on to the next lesson. And I thought I was being maybe a little too aggressive with it. But again, based on these numbers, as it's running right now, we have moved on to the second lesson at about a quarter of the way through the run. So we'll see how it does. There is some hope for this yet. So that's where we are with there. So the distance scale and collision points, again, I'm changing how hard the problem is, and I'm also changing some of the weights. So that goes into a JSON file. And let me pull up the directory here. Here we go. And so that goes into a JSON file that just hangs out with all of the other files. Unfortunately, because it is a JSON file and it is a very strict JSON parser, you can't put any comments in there, so it's a little hard to version those if you just want to try a bunch of new variables, because it also checks the variable names here, like this distance scale and on collision points, and if those variable names don't exist in my environment, then it will halt. So it's not like you can comment it out or just, put a nonsense name in there or something and then, just run with it. You basically have to do file-wise versioning, which is why I don't have a great log of all of the different runs that I've done, because I didn't want to sit around and have literally a dozen curriculum JSON files in my directory. So I was just going in and editing this. So that is an overview of the curriculum learning, and while I'm here, I will go ahead. I have a comparison, and so here is a algorithm that is, here's our game trained with 3 different algorithms. So in the back, I believe, is PPO. Yep. So in the back is PPO, and this is our 10 million iteration best of breed PPO. And then in the middle is our imitation learning. And then in the front is our curriculum learning example. So one of the things you will see is that this does have emergent behavior, right? It's interesting because you'll see this guy like spin around and then thrust backward to slow down. So it's kind of interesting. It apparently along the line learned that just by doing these little curly cues in the air close enough to the target was a better way to get score, right? And that's the kind of emergent behavior that you can get with PPO or with curriculum learning that you're unlikely to get as much with for imitation learning. So you'll also see imitation learning lands things fine, the standard PPO lands things fine, and then at this point in time, the curriculum learning, it lands sometimes and it has some interesting behaviors. But again, this is at 2 million iterations, so if we gave it another 8 million iterations, I'm sure in many cases it's going to be of similar skill to the one in the back. So, doing the side-by-side comparison. So the question is, should you use curriculum learning? And the answer is, it kind of depends. If you just want a quick and easy way to parameterize some stuff, and as you're experimenting with what your values and parameters need to be, then it's certainly worth at least just putting that JSON file together so that you can do that. If you have a very specific target that, or a very specific objective that is hard for the system to kind of find on its own, then curriculum learning is another way to guide your application or guide your machine learning weights toward that goal that you think you have. And again, there have been other cases where, again, when you're building up more and more complex behaviors, you establish the simple behaviors, and then over time you make them more complex. And again, an example of that is, in my case, where I established the don't crash behavior, and then we tried to get more complex, but it never really learned the more complex stuff. And maybe I should have just run it longer. But, it really learned the don't crash part, and then it didn't actually learn the go toward the reward to get a reward part. So no free lunch, interesting technology, absolutely worth trying in certain cases. And I mean, the good news is you don't have to do a 10 million iteration run in order to get a result. You can, quickly run a few of these at a much lower number of iterations so that you can get a feel for if it's helping you or not, or if it's basically amounting to the same thing that PPO is. So there you go. That's my take on curriculum learning. And in the next video, I'm going to go into details about how to actually implement curriculum learning in your application.